Hello everyone. So welcome back to the video lectures on image and speech processing. So in our previous videos, we have talked about image compression models. In our previous video lecture, we have talked about Huffman and Shannon-Fanon coding. So which is a lossless compression model, right? So in today's topic, we'll be talking about our arithmetic coding, right? So as we have talked in our previous, there are two types of coding techniques. There are two types of coding techniques. One is the lossless, the other is lossy, right? So in lossless, we have different types where we, in our previous video, we have talked about Huffman. Second, we talked about Shannon-Fanon coding, right? So the third type of lossless coding that we can is the arithmetic coding. So arithmetic coding is also a type of lossless coding technique. Okay, right. So what actually is arithmetic coding is, it is inversely proportional. The number of bits is inversely proportional to the probability of intensity, right? So it is a, we can say it as the variable length coding technique. It is a variable length coding technique, and there is this difference between arithmetic coding and Huffman coding. How is that? So let's go in here. So arithmetic coding is, it is complex for short message, whereas it is very simple for short messages. Let's say suppose we have A, B, C. Okay, so doing arithmetic coding is like a tedious coding technique, whereas when we go for Huffman coding, it is very much simpler, right? So arithmetic coding gives us the optimum result. Like when we try to decode back from our coded signal, then arithmetic coding gives us the optimum result. Whereas Huffman coding is good enough, but not that when compared to arithmetic coding, right? The next thing is the one-to-one correspondence between the source and the code word doesn't exist, right? Whereas the one-to-one code correspondence exists. That means if in our Huffman coding we have seen that if A is there, a code symbol, then we have the coded word as, say suppose 0010, right? Whereas when we go for B, so 100, so we have a code symbol or a symbol and it has a code word, right? So this is called as the one-to-one correspondence. Arithmetic coding does not have the one-to-one correspondence. Why it doesn't have, we will see in our example when we go, right? So here, if we observe here, what is the advantages of arithmetic coding is compression ratio is more, right? So compression ratio is more. When here Huffman coding, the compression ratio is less. So when we are trying to compare this arithmetic coding as well as the Huffman coding, we are comparing. So that is why the compression ratio is better than Huffman coding. But Huffman coding compression ratio is good enough. But when we are trying to compare with the arithmetic coding is more, right? Execution time is more because, as I said, it is a little bit of tedious process, and execution time is less, right? Now, what are we doing in arithmetic coding is, instead of assigning single intensity by some code word, like how we have said, single intensity A value, single intensity B value, and we're giving a code word, right? So that we are doing in Huffman, Shannon-Fanon coding. So instead of that, what we are doing, we are taking the whole ABC combination, which is the code word. So A is called as the code symbol. Where ABC is called as the code word. So what are we doing in arithmetic coding is, we are taking the entire sequence of the code symbols, which is called as the code word, right? And we are giving one single arithmetic code. Okay, so arithmetic, we are giving a single code. What is that code? We are giving it as the arithmetic code. So it will either be 1, 2, 3 numbers. Instead of having this binary values, we will be representing it using arithmetic code. So because of this, the execution time is more, it is a tedious one, and it is complex for short messages. And because of this also, since we are using an entire sequence of code symbols, and we are giving it as a single code, it is, that is why we are saying one-to-one corresponding does not exist, and it gives an optimum result, and as well as we will have the compression ratio as more. Right? So these are the advantages of arithmetic coding when we are comparing with Huffman coding. Huffman coding, and it is very similar to, we know that Huffman coding is very much similar to our Shannon-Fanoff coding, right? So we can say that when we are comparing arithmetic coding with Huffman and Shannon-Fanoff coding, arithmetic coding is much better. Right? So what are the steps that we have to follow when we have to do the arithmetic coding? We will see now. So what is the first step? We will divide the range 0 to 1 into sub-ranges. Okay, why are we considering the range 0 to 1? Because we have probabilities, right? We have probabilities, right? So we have probabilities which will be belonging to the range 0 to 1. So we have the range 0 to 1. So that we are dividing into sub-ranges. How are we dividing? The length equal to the probabilities, right? So say suppose I have 0 to 1, I have my value as 0 to 1. So I am dividing into, say suppose 3 I have 3 symbols and I am dividing it in the 4 sub ranges. So how am I doing it? As I am saying that the first sub range is say A, B, C, D. Then this value is given by the probability of this A symbol. Say suppose it is 0.2. Similarly 0.3, 0.7, like that. Okay, so we are having the range 0 to 1. Why we have the range 0 to 1? Because we are talking in terms of probability of the symbols A, B, C. So we will have the range between 0 to 1. So that range we are dividing into sub ranges. So how many sub ranges? That will be depending upon the number of symbols that are having, or the number of possible intensity values that we have. Then what will be the length of the each sub-range value will be equal to the probability of their occurrence, right? So that is how we are going to divide. Next, what are we going to choose? We are going to choose the range which is depicted by the first symbol in the code word. Say suppose I have my code word ABC, right? Say suppose I have my code word ABC. Then what am I choosing? Since my first sequence or the first symbol that we are talking about is A, so in this sub range, I will choose the sub range which is represented by this symbol A. So that is given by 0 to 0.2. Right? Is it clear? So after that, what we do is we divide the chosen range, this range which is given by the first symbol A here. So that we are going to divide the chosen range and repeat the steps 1 and 2 till all the symbols in the code word are coded. Right? So that is what we have done. Now after we choose the new range 0 to 0.2 in our example here. Right? So now how are we going to do the step of dividing the range 0 to 0.2 and get these probabilities, sub-range length and all? It is given by this equation. So let me just, so this new subgroup divisions are calculated as first group division, end division is given by the starting range value plus range length into probability of my symbol, right? So next is what am I going to get the second subgroup as? Second subgroup as first group end division, which is given by this value, plus the range length into probability of this second symbol, right? This is a first symbol, this is my second symbol. Similarly for my third subgroup, right? So fourth subgroup and so on and so forth. So how many subgroups I will have? I will have the number of subgroups will be equal to the number of symbols that are existing, right? So we will go on divide till how many subgroups we will consider? Till all the symbols in the code word are coded, right? So that is how we do our arithmetic coding. So let me just explain it better more using an example, right? So I have the arithmetic code. Okay, I have to use my arithmetic code, and I have a sequence as CAB, right? So if it was I have been given the intensity and probability, right? If I'm using a Huffman coding, so what do? I arrange this in the decreasing order of my probability, and each 0.6, 0.3, 0.1 I will add, I'll get it as 0.4, right? So this is giving as the 1. So this is my forward steps. If I have to do my coding, I'll do my backward steps and code it. So how do I do it? So 0.6 and 0.4, 0.6 is greater than 0.4, so I'm giving the value as 1. 0.4 is given the value as 0. So 0.4, how did we get? We have got by adding these two values. So what am I doing? I am writing it as 0, 1, 0, 1, 1. 0.6 is given as 1. Now if I have to code the value sequence CAB, so how do I do? C is represented by 0.1, which is given by the code word 1, 1, right? Next is A, which is 0.6 probability, so that is given as 1, right? Next I have the code symbol B. So B, I have the intensity value as 0.3, that I have the representation as 10. So if I have to represent the sequence CAB, I'll be using this sequence, right? If I'm using my Huffman coding, right? Whereas when we come for arithmetic coding, it is different from the steps. So how are we doing it? Let me just erase it for a minute, right? So how are we doing it? Where first step is, we are going to divide the range 0 to 1, right? So what is that range? We have the range 0 to 1, right? I have my range. How many subgroups I have to divide? I have to divide it into 3 subgroups, so that I'll represent my each subgroup by each of my symbol, right? So I'll say, right? So first subgroup, second subgroup, and third subgroup. So first subgroup I am representing it by A. Second subgroup I am representing by B. Third subgroup I am representing it by C. Now what is this value? How do I get this value? That is given by my probability, right? So that probability I'm going to write it as 0.6, and this is 0.3, right? The length should be 0.3. So how do I write it as 0.3 plus 0.6? So which is given by the value 0.9. Now the end value C is given by the probability 0.1. So the length should be equal to the 0.1. So this we get as 1, right? So the range 0 to 1 is divided into 3 subgroups A, B, C, where each subgroup length is given by the probability. So which is given by 0.6, 0.3, 0.1. So I am writing my subgroup as 0.6, 0.9 and 1. So I have my sequence CAB. So I have my sequence here CAB, right? So what is it C? When I am dividing my range 0 to 1, how is my C represented as? It is represented by the sequence 0.9 to 1. So I will consider this range as for my second stage. So this is my first stage. So my second stage will be, my new range values will be 0.9 to 1, right? So this value will be 0.9 to 1. So how we will continue these steps again, which we have followed, dividing it into subgroups like this, and calculating my values, right? So how many subgroups we have to divide here right now? We have to subdivide it into 2 subgroups, right? So which is given by 2 divisions. 3 subgroups by 2 divisions. So what is this value now? If this is given by the symbol A, symbol B, symbol C, now what is the division here? This value is required, right? So that is a question mark here. So how do I get it here? We have discussed in the previous slide, that it is given by the value 0.9 plus, because that is the starting one, right? Plus what will be the length of this what is be the length of this subgroup? What is the length of the subgroup, which is given by 0.1, right? Into what is the probability of A, that is given by 0.6. So that value we get is 0.96. So this subgroup value is given by 0.96. Right? Now, next subgroup range value, how do we get? We get it from by adding 0.96, because this is the starting range for this value range, plus what is the total length of this my subgroup as 0.1 into what is this value? Probability of B, that is given as 0.3. So that value we get it as 0.99. Right? So, fine. Now, to verify whether our calculations are correct, so how do we do? So this is 0.9. So if I want this value, so how do I get it? I have to calculate it as 0.99, this value. How do I calculate it as 0.99 plus 0.1 into 0.1? So that is equal to 1, right? So this shows that my calculations of 0.6 and 0.99 are very much correct, right? So this is given by 1. Now, what is my second sequence? My second sequence in my second symbol in my sequence is A. So what range I have to consider? I have to consider this range 0.9 to 0.6, right? So let me just here just yes. So this is 0.9 to 0.96. Now what is this length here? Length of my subgroup, new subgroup, is equal to 0.06. Now how many subgroups we have to divide it into? I have to divide it into 3 subgroups with 2 divisions. So what is this value? How do I get it as? I'll get it as 0.9 plus what is my length? 0.06 into, so what is the probability of the symbol A, B, C, right? So what is the probability of A here? We have value as 0.3. So that value, how do I get it as? 0.9 plus 0.1. 0.018. So that we are getting it as 0.18. Right? Now, this is 0.918. So what is this value? How do we get it as? 0.918 plus 0.06 plus 0. The probability of A is 0.6. So this value will be 0.36. So this value is 9.36 plus right here. So this value is 0.936. Right? Okay, 936 plus 0.06 into 0.3. Right? So 0.936 plus 0.018. So I get the value as 0.18. So I get it as right 0.954. So what will this value? My question mark now becomes 0.954. So what will be the my, if I have to check whether my calculations are correct, I have to calculate this range. So how do I get it as? 0.954 plus 0.06 into 0.1. So what is that value as? 0.954 plus 0.06. So that will come as 0.96. So my values, my calculations are correct. Right? Now, I have my sequence as CAB. Right? I have taken in my first step, I have taken the range which was representing by the symbol A. In my second stage, I have taken this range which was represented by my symbol A. So, I have already coded in my sequence CA. Now, what is the symbol that is left out? Is B, right? I have coded A, C and A. So, I have the code symbol now. B, which I have to code. So, what is the range that is being represented by B? It is equal to 0.936 to 0.954. Right? Now, if I code this, I will represent if I take the code value which is ranging between 0.936 to 0.954, I'm going to represent it by my sequence CAB. I can choose any value which is ranging in between 0.936 to 0.954. So I can take the value as 966. Some can take the values as 94. Some can take 0.95102. So any of these values is appropriate for my code of my sequence CAB. Right? So how did we do? How did we code it? There is no one-to-one correspondence between each of my code symbol with my coded word. Say suppose I am using the sequence CAB, I am coding it by arithmetic value 0.9366. So this value is an arithmetic value, so we are calling it as arithmetic coding. Now, if we observe here, this complete sequence is represented by 0.9366, but we cannot specifically say that C is represented by so and so range, A is represented by so and so range, and B is represented by so and so range. So this complete thing can be represented. We can decode back, but when we are coding it, we cannot pinpoint and say that C is represented by this sequence, right? So one-to-one corresponding is not existing here, right? So let's go to another example on my arithmetic coding. So what are we doing here? In my first example, we have considered about coding. So in my second example, we'll try to decode a message, right? So we will try to decode my message. How are we going to do? We are going to follow the same procedure what we have done before, right? So what is that? We have the message 0.2355, right? Now we have been given intensities and probabilities. So what we are to do, so we will follow the same steps that we are following for coding. Same steps we are going to follow. So what is the first step that we are going to follow? We have the values as 0.0 to 1. Right? So how many subgroups we have to decide? We have number of symbols as 1, 2, 3, 4, 5, 6. 6 sub. So we require 6 subgroups. So we will have 5 divisions. So 1, 2, 3, 4, 5, 6. Right? So 6 subgroups we have. So the first subgroup we are going to represent it by R1, R2, R3, R4, R5, R6. Some may say that why am I representing my first subgroup by R1? Because the order of my given question is R1, R2, R3, R4, R5. So the same intensity, same group, same order I am considering. So I have R1 which is equal to 0.2. So in my first stage, these values are given by my probabilities, right? So this is equal to 0.2. Now R2 is values given by 0.3. So how do I get it the values as this subgroup value? 0.2 plus this value length will be 0.3. So that is equal to 0.5. Next, here I get the values as 0.6 because the probability value is 0.1. Next, I have 0.8. Next, I have the value as 0.1. Next, right? So the first step is clear. Now, I have been given the range 0.2355. So where does the range 0.2355 exist? It will exist in this range, right? So this will exist in my R2 range. So this I'll just round it. Okay, so R2 range I'm going to consider in my second stage. So in my second stage, my new subgroup is new range that I have to consider is 0.2 to 0.5. Let me just increase it a little bit. Yes. So this is 0.2 to 0.5. I have to divide it into 6 subgroups again. So 1, 2, 3, 4, 5, 6. Right? Now, what is this value? This first subrange is given by R1, R2, R3, R4, R5, R6. Right? So I have to calculate this value. So how do I get this value as 0.2 plus what is the range now? Range length is equal to 0.3, right? into what is my probability of R1, which is given by 0.2. So this value is given by 0.26, right? So this value is 0.26. Next value is given by 0.26 plus 0.3, which is the range length, into what is my probability of R2, which is given by 0.3. So this is equal to 0.26 plus 0.9, which is equal to 0.35. So this is equal to 0.35, and so on and so forth. The values exist, but let me not go beyond it, because I have already got my range value here, right? So the value 0.2355 is existing here in this, the first range. So the symbol that the range which I am going to consider is for my R1. So what is the range? 0.2 to 0.26. So I just go here. This is my third stage. So 0.2 to 0.26, right? So the same three subdivisions: R1, R2, R3, R4, R5, R6, right? So this value is given by now 0.2 plus what is the range length now? 0.06 into what is my probability of R1? What is my probability of R1? It is 0.2. So this is equal to 0.2. This is given by 0.22. Right? So next 0.22 plus 0.06 into R2 probability value is 0.3. This is equal to 0. This is correct. 0.6 into 0.2 is equal to 0.212, right? So this is equal to 0.212 plus 0.6 plus, so that is 212 plus 0.018, which is equal to 0.23, right? So this is given by 0.212, this is given by 23. Next is 0.23 plus 0.06 into what is the probability of R3? R3 value is 0.1, right? So we get the values as 0.236, 0.236, right? What is the range that we are talking about? 0.355, right? So my first stage, second stage, third stage here. So I have to consider this range as R3, right? So this value is existing between 0.23 and 0.236. So my fourth stage I'm considering here. So I have the value 0.23, 0.236, right? So this is R1, this is R2, this is R3, this is R4, R5 and R6, right? So if I have to calculate these values, what do I get? 0.23. Now my new range length values is 0.006 into 0.2, which is the probability of R1. So that value is 0.23 plus 0.0012, which is equal to 0.2312. So 0.2312. So next is 0.2312 plus 0.006 into 0.3, which is equal to 0.23 plus 0.0018. And get the values as 0.24. Get the value as 0.22. I get the values as 0.232, right? 0.232. Next, continue. I get the values as 0.235. So this value I get it as 0.36. Okay, say suppose. So now my range value is falling in the range R4, right? So how many stages do I have to go beyond like this? So that is given by the number of letters or the number of decimals that we are having. We have the decimal value as 0.235, 0.2355. So how many stages? First stage, second stage, third stage, and my fourth stage. So the number of decimal points that are existing after the decimal, how many letters or how many numerics I have after my decimal point will give the number of stages that I have to follow. So I have 4 here, so we will stop at my fourth stage. Now what is my decoded message for this will be given by the rounded values. So my rounded values are R2, R1, right? So R2, R1. So I have R2, R2, R1. Next I have R3. Next I have R4, right? So if I have my sequence of my symbols as R2, R1, R3, R4, it has been coded as 0.2355. Okay, so when I try to decode back from 0.2355, I get the sequence as R2, R1, R3, R4. You can recheck back by using arithmetic coding technique. If my sequence is R2, R1, R3, R4, I'll get my sequence, this range as 0.355. Right? So this is my arithmetic coding. So we are following the reference, which is the digital image processing, which is given by the Gonzalez. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.